A very good morning, learners. I hope that you are doing well and keeping safe. Today, the topic that we'll be discussing is a very interesting one because it is based on the object that we use each and every day as part of our lives, which is basically used to lift objects that we use on a daily basis. So basically, our technology lesson is based on pulleys because each and every day on our daily lives we are using something that we call as a pulley. A pulley is basically a wheel with a droved rim around which a cord passes, which acts to change the direction of a force applied to the cord and is used to raise weights. Basically, a pulley, it is something that we use to pull an object upward, something that we use to retrieve an object upward. So now what I'm going to do, I'm going to to demonstrate or to show you a typical example of a pulley, because when you are talking about a pulley, we are not merely talking about an object, but we are talking about an object that can also be analyzed, because what I want you to understand is that a pulley, it has many facets that are embedded with it, because you should show how a pulley is calculated, because it includes some parts of calculations. So I'm going to use this poster so that I can demystify, or I can make it easier for you to understand what a pulley is. So basically, a pulley is something that is looking like this. For instance, we can use 50 newtons. That is how you calculate basically what is you calculate a pulley. We can use 50 newtons, then we can use 200 newtons. So basically, to understand the distance between the effort and the load, this is 50 newtons here represent the load, and 50 newtons here represent the effort, and 200 here represent the load. So we should calculate the distance or the mechanical advantage that is going to be needed so as to pull our load. So we are going to divide by we are going to divide we are going to say 200 divide by 50. Why are we dividing by 200? It's because 200 is our load, so the load is divided by the effort that is needed to lift the load. So a typical example will be we are going to say like this: 200 divided by 50 is equal to 50. So why am I reiterating this? Is because the load is 200 and the effort that is going to be needed to lift the load is 50 newtons. So basically, what are we looking at here? We are looking at how much energy, how much mechanical advantage do we need to lift our load using the effort, because the load cannot be lifted without the effort. So I hope that is going to be clear enough for you. So this is our poster in full, and these are our typical examples that we have used. So this represents the effort that is needed to lift the load, our load, which is 200 newtons. So what you do, basically you divide the load by the effort, because for you to be able to lift the load, you will need the effort, because basically what is lifting the load is the effort. So now I'm going to show you a typical example of how does a pulley work. Just to reiterate what I've said before, a pulley is something that is used to lift objects. As you can understand that on a daily basis we are using pulleys, or we are using machines to lift objects up. So as you know that South Africa is a water scarce country, so as technology students we need to come up with solutions so as to counter, or so as to facilitate the process of coming with suggestions as to how we can help to manage the water crisis in South Africa. I think for that, as technologians, or as technology learners, we need to come up with something so that we can help the government to alleviate the water crisis. As technologians, or as technology learners, you need to know that not everything is facilitated through using big machinery, or using things that are going to be very, very costly. To alleviate the water crisis in South Africa, we can simply use what is known as a pulley. So basically, a pulley is something that is cost effective. What do I mean by cost effective? I mean that it is not costing a lot, rather it is costing less. So basically, to alleviate the water crisis, we can use a pulley, because a pulley can be used manually. It does not need a lot of electricity, rather it is a structure that is constructed to do the job. So I'm going to do a demonstration here of how can we use a pulley to counter the water crisis in South Africa. As I've explained that for us to be able to alleviate the water crisis in South Africa, we need to come with solutions, and the solution includes a pulley. So this is a model that I've chosen to use as a demonstration to you to see how does a pulley work. This is our pulley. This is our machine. So to solve the water problem, we are going to use this model to demonstrate how a pulley works. So we are going to pretend as if this is the water hole, or the water well, where we are going to retrieve water using the pulley. We are going to retrieve water from underground using our pulley. So this is how this is going to work. This is our hole. So the load in this instance is the water that is going to be retrieved from underground. So this is the load. The load is going to appear, and this is the effort. The effort is the wheel that we are going to use to retrieve the water from underground. So let's go. We are retrieving our water from underground. So we are using our wheel to retrieve the water from underground. So there is our wheel. This is our wheel as it appears from underground to retrieve the water. So this is our load as it is appearing from underground to lift the water. I hope you can see. So this is our wheel. There is our load as it is lifted by our wheel. Mind you, the load is the water that we've just retrieved. Then the effort is the wheel that we are using to retrieve the water. So there is our load as it is coming up. So we are using our wheel, which is an effort to retrieve our load from underground. So there is our wheel coming up. Just to demonstrate for the last time, this is the load. In this instance, the load is the water that is coming, is being retrieved from underground. So the effort is the wheel that we are using to retrieve the water underground. There is our effort coming. There is our load coming up as being retrieved by our effort, which is the wheel. So this is just a cost-effective a plan to solve the water crisis in South Africa. As I have explained, this is our well, or this is where we retrieve water from underground. So the load in this instance is the load here is the bucket. So our bucket is coming from underground to retrieve water from underground. So for us to be able to retrieve our bucket, we have to use the wheel. As you can see that our wheel, as we are pushing, as you can see that our load is coming up as we are pushing the wheel, which is serving as an effort. So it is coming up. So if we want to retrieve water again, we can just push our wheel towards the left to come down. Then when we are done with when the bucket is done retrieving the water, we can simply push our wheel, which is an effort to lift our load. Our load in this instance is the bucket, to lift it up ground.